Hey, what's going on, everybody? Welcome back to our channel, where we make coding simple, fun, and easy to understand. If you're just starting out on your programming journey, you're in the right place. Today, we're diving into one of the most fundamental and essential algorithms, linear search. Now, imagine you've misplaced your keys somewhere in your room. What do? You start checking every spot one by one until you find them. That's basically linear search in action. In this video, we'll walk through how linear search works, break down the concept step by step, implement it in C++, and see exactly why it's such a powerful tool for beginners like you. Before we get started, make sure you have a basic understanding of programming concepts like loops and arrays. If you're familiar with those, you'll have no trouble following along. So, grab your notebook, a cup of coffee, and let's jump right into understanding linear search. Let's start with the basics. What exactly is linear search? Linear search is a simple algorithm used to find the position of a target value in a list. It works by checking each element of the list one by one, starting from the first, until it finds the target or reaches the end of the list. Imagine you're searching for your favorite book on an unsorted shelf. You go through each book one by one until you find the right one. That's practically linear search. Now, you might be wondering, when should we use linear search? Well, it's perfect when the data isn't sorted. The list is small. You want a simple solution without much complexity. Let's break it down step by step. Suppose we have this array, 357291. Our goal is to find the number 7. Start at the first element. Is 3 equal to 7? No. Move to the next element. Is 5 equal to 7? No. Keep going until you find 7. Once we find it, we return its position, which in this case is index 2. Remember that index always starts from 0. Now that you have a clear understanding of how linear search works, you're ready to apply it in your own projects. Alright, let's see how we can code this in C++. It's super simple. Watch closely. I already have the boilerplate code written in C++ here, and I am using the std namespace here, so I don't have to write that scope resolution operator anywhere. Inside the main function, let's create our array or list of some elements. Integer, array, square brackets, equals, inside the curly brackets, let's give some values randomly, 2, 6, 3, 0, 9, and 5. Then we have to calculate the size of this array. Integer, size, equals, size of array, divided by the size of array, at index 0. Now let's define our target. Integer, target, equals, let's say we want to find the element 9. That's it. We're all set. Our next step is to create the linear search function. Integer, you can name it anything. I am writing linear search. It takes 3 parameters. Integer, array, integer, size, and lastly, integer target. Now, we have to write a for loop to iterate through each element of this array. For int I equals 0, I less than size, I plus plus. Now we have to check each element using if statement. If array at index I equals to target, which means we have found the target. Just return I, which is the index, outside the for loop. If the target doesn't exist in our array, we have to return -1. And that's it. Everything is set up. Now we have to run that function on our array. Integer, result, equals, linear search. Pass the parameters required. First one is array, second one is size, and last one is the target. Let's print the result in terminal. Character output, result. Let's run our program. As you can see, it gives index 4. But if I change the target to an element that doesn't exist in array, let's say target equals 10. If I run this, it gives -1. I hope everything is clear now. Let's talk about the time complexity of linear search. In the worst case, we might have to check every single element. So the time complexity is big O(n), where n is the size of the list. And for space complexity, it's big O constant because we're not using any extra space. Here's a quick look at its pros and cons. Pros: simple to implement and works for both sorted and unsorted data. Cons: inefficient for large datasets since it's linear. And that's linear search in a nutshell. It's a great starting point for understanding search algorithms. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more algorithm breakdowns and coding tips. Let me know in the comments what algorithm you'd like me to cover next. Until then, keep coding and stay curious. See you in the next video. Thanks for watching.